Okay, let's do a video on exponential growth and exponential decay. Here's my example that I've made. We've got two rabbits and they live in rabbit land. It's really inventive. That's our initial value. Okay, they're growing at a rate of 0.8. They're at it like rabbits. Our rate. Okay, and the first bit of the question says we've got how many rabbits after 5 years. That's our time. So what we're aiming for is the population, which is y. To get this, we've first got to write down our initial value. We know that's 2. Then we've got e. Then we've got our rate, which is 0.8. And we've got our time, which is 5. So we can simply put that straight in to a calculator and we get 109 as our answer. So 109 rabbits. Our second part of the question says how long till 1000 rabbits. This means we're aiming for the population of 1000. So, and we already have our initial, which is 2. E. We have our rate, which is 0.8, and then we're just aiming for the time. There's two methods of doing this. The first method is by using logarithms. Logarithms, to start off, will divide the 1000 by 2, so we get 500. We're going to equal that to e 0.8 t. Okay? That's just simplifying it. Logarithms, then we add the logarithms, natural logarithms. ln 500 is equal to ln e 0.8 t. Okay, then using log rules, we know that we can move 0.8 and t to the front and it's exactly the same, it doesn't matter. ln 500 is still equal to 0.8 t ln e. Okay, then we can have ln 500 divided by, because with our rules, if it's multiplied on this side, we can move it over to that side, and you can divide ln e equal to 0.8 t, and then you could put it into the calculator now if you wanted to, but to make it even more simple for ourselves, we're going to go ln 500 divided by ln e, all divided by 0.8. And that should get t straight off. And there we can see our time is 7.768. 7.768. So that, if we really want to get the days, we could go 0.768 times 365, and we get about 280 days. So 7 years and 280 days. That would be the answer to our first question. However, if we want to do a second option, all we want to do is go back to this step here, this one. Okay? And we've got to use a formula which goes n is equal to ax will be reversible with x is equal to log a n, or Logan if you want to say it like that. Okay, Nax is equal to Logan. It's the same, it's reversible. Right, and we're just going to write down 500 is equal to e 0.8 t. So you do exactly the same up to that step, and then this is the other method. The other method is to just interchange these. So what we're doing is, we can see these are completely reversible. So x is the first value. X in this one is 0.8 t. 0.8 t is equal to log a, which in this one is e, n, which is 500. Then rearrange it again, so we end up with t straight away, log e to the 500 divided by 0.8, and then we can put that straight in our calculators. And as you can see, we've got exactly the same value as we got last time, 7.768. Okay? However, not is all good for the people of Rabbit Land. The Slender Man has came to Rabbit Land. A very badly drawn Slender Man. So, at a time where there's 1,000 rabbits, which is our initial, the Slender Man decides he wants to kill them all. It's predicted that 50%, so 50% of our initial, is our population, 500. We'll be gone in 2 years, so that's our time. We don't have a rate by 2. So, we want to know what is the rate of decay to start off with. So, the rate of decay. First, we'll simplify it a little bit. So, 1/2 is equal to e the minus 2r. Okay? We're going to add some natural logarithms. We use the same rule again, moving that over there. ln 1/2 equals to minus 2r ln e. Then we can move this over here like we did before. ln 1/2 divided by ln e is equal to minus 2r. Okay, I made a mistake in my working. I've got to be honest about it. Don't worry, everyone makes mistakes and they are good. Okay, you learn from mistakes. What we need to do is now we ln 1/2 divide that by ln e. So the whole lot of that is then divided by minus 2, and we will get the positive value of our exponential decay. We want the negative value, so just put a negative on it. As you can see, positive value 0.3465 dot 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 dot. Yeah. So 0.34 dot dot dot. So we want minus 0.34 dot dot dot. That is our rate of decay. And this allows us to then go on to the next question, which is how many years will be passed when 90% of the rabbits are dead. So we've got our initial value, which is going to be 1,000. We've got our rate of decay, which is minus 0.34 dot dot dot. Remember, you want to keep that into your calculator. And we don't have our time, but we've got how many we want, because it's 90%. So we're getting rid of 90% of the rabbits, so we have 100 rabbits left. Okay, oh, don't forget your value, that's a bit stupid. So then, do some simplification. E minus 0.34 t. Okay, I'm going to use logs for this one. From the ones we've done before, we'll go straight into minus 0.34 dot dot dot, don't forget the dot dot dot, t to the ln e. Then we do a divide, ln 110 divided by ln e equal to minus 0.34 dot 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 t. We're nearly there. ln 110 divided by ln e divided by minus 0.34 dot dot dot. So that's where you want to keep it in your calculator, so you can just have it as ants. And now you put that into your calculator, you should get t. And there you go, 6.6438 dot dot dot. So that's your time to get rid of 90% of the rabbits. That's your time.